This is Mr. Beck Does Your Homework. This is physics homework number 5, questions number 4 and 5, a two-part problem. It says, a driver of a car traveling at 17.6 meters per second. Now wait a second, 17.6 meters per second. That seems like the velocity that it's going initially is 17.6 meters per second. So I'm going to write V0 is 17.6 meters per second. This car applies the brakes, causing a uniform deceleration of 1.8 meters per second squared. My acceleration, 1.8 meters per second squared. But wait a second. This car is driving to the right, let's say, in a positive direction, is my velocity. So in order to, when I put on the brakes, if I'm having a deceleration of 1.8 meters per second squared, that's telling me that my acceleration is in the opposite direction of my velocity. So if my velocity is positive, I'd better put in a negative for my acceleration. I'm decelerating, I'm negatively accelerating. How long does it take? That's time. Time equals question mark. How long does it take the car to accelerate to a final speed of 15.5 meters per second? So my final speed is going to be 15.5 meters per second. So it's traveling along at a quick velocity. Sometime after the acceleration, it's got a new velocity, and that new velocity is less than the initial velocity. So it's slowing down. How far does it travel is what I'm looking for, is how far it goes. So I need an equation that has initial velocity, acceleration, time, and final velocity, but no displacement, because I'm looking for, I'm not looking for that yet. I'm looking for the amount of time that it takes. Question 5 is how far it goes. So now I'm looking for the amount of time it takes. If I want to find out the amount of time it takes without knowing the distance, because I don't yet, then I want the equation that doesn't have distance in it, and that is my first equation that says V equals V0 plus acceleration times time. So I'm looking for time. I could rearrange this equation, which is sometimes a good idea, in order to solve for the variable you're looking for. I'm going to do that. So I'm going to subtract V0 from both sides. So I get V minus V0 equals AT. Now I'm going to divide by A. So I get V minus V0 over A equals T. So if I plug in some numbers here, I get my time equals my final velocity of 15.5. minus my initial velocity of 17.6 divided by my acceleration of negative 1.8. And that's going to be my time. You'll notice that it's a small number minus a bigger number, so this is going to be negative. This is already negative, so those negatives are going to cancel out and give me some positive value of time. Units on top are meters per second. Units on the bottom are meters per second squared. So I've got units here of meters per second divided by meters per second squared. Well, if you divide by a fraction, that's the same thing as multiplying by the inverse. So that's meters per second times seconds squared per meter. If I flip this and multiply, now you'll see meters cancels out, one of the seconds cancels out, and I'm left with seconds. So my units are going to be seconds. Now I'm up to the second part of the problem, which says how far has the car moved during the braking period? Well, what if I use the equation without time to figure out how far the car moved? That equation says that my final velocity squared is my initial velocity squared plus twice my acceleration times my displacement. So my final velocity squared is going to be 15.5 squared equals my initial velocity squared is 17.6 squared plus twice my acceleration of negative 1.8 times my displacement. You'll see that this number is going to be bigger than that. When I subtract it, this is going to be negative. Then I'm going to divide by 2 and divide by negative 1.8, so I'll be back to a positive number, and so I can solve this and get a value for my displacement. My units, this is meters per second, and when I square it, it's going to be meters squared per second squared. This is also meters squared per second squared, but when I divide by meters per second squared, I should be left with only meters. So this is going to be in meters, as my displacement always is.